Okay, sir. All right. Welcome once again to your study part where we bring you the best in terms of quality academic delivery. Today we'll be looking at two key aspects of our UTME examination, talking about heat and electricity. Now, what is the focal point as far as these two aspects are concerned? We want to look at exactly how best we can identify and solve questions that involve ratios. Remember, the last class we had, we were able to constructively look at questions that involve Roman figure tags in the sense that you have Roman figure 1, Roman figure 2, Roman figure 3, Roman figure 4, and you're expected to pick options that vary around these Roman figures. Adventure, you were not available while we were having class of that. You can always what? Call on us. The numbers are always displayed on various social media platforms which we operate. Give us a call. You'd have access to what? These video clips. Remember, it's not limited to only physics as a subject. Talking about your math examination, talking about your English, and many more. You have access to it. And it's just less than 1 month to go at an affordable rate. Note, at an affordable rate. So here is it. Questions on the Roman figure tags. We've actually dealt on it last week. Today, trust me, you have something loaded as well. In picking questions involving what? Ratios. Specifically, go check throughout your Jamb past question. You see that what? It is specific on heat and temperature as well as what? Electricity questions. So, the heading for today will simply be questions involving ratios. Let's make it bigger. Questions involving ratios under heat and electricity. Under heat and electricity. So this will be the focus for today. So we have this as the focus. Let's look at basic questions that can pop up in your UTME examination because this is the trap most times students get themselves entangled with. And why am I saying it's a trap? When you see questions involving ratios, trust me, they are calculation questions. I repeat again, when you see questions involving ratios, they are basically what? Calculation embedded questions. So you want to ask yourself, along the course of solving questions under these topics, am I in for this if I should see them? Or I push on to other questions, then come back later to address them. Question one for the day. Let's look at it. Remember, under heat and under electricity. Under heat and also under electricity. The first question under heat has this to say. Number one, when two objects, when two objects, P and Q, are supplied with the same quantity of heat, the temperature change the temperature change in P is observed twice that of Q. Full stop. The ratio of the specific heat capacity of P to Q is question mark. So this is what we have as the question. You can ponder on it for some few seconds before we go about solving it together. All right. You can ponder on it to see if it's something you can easily what? You can easily attempt. When two objects, P and Q, are supplied with the same quantity of heat, note that the temperature change in P is observed twice that of Q. Then we are told that what? The ratio of the specific heat capacity of P to Q is what value? What ratio are you going to have? A question like this, basically, automatically, is a calculation question. So you should have that at the back of your mind. When questions like this come, can I answer it? Figure that out. And I used to say this, whenever you see questions a bit lengthy as this, what you want to identify, do I know the formula? If you don't know the formula embedded around the topic, then please stay clear of it. At the moment, I never said leave any question in your UTME examination unanswered. I said save it for the last. Go attempt other questions, then come back. Along the line of dealing with other questions, you might see something related that gears up the formula back. Now, to solve this quickly, we know that this is under specific heat capacity. And talking about heat energy, quantity of heat, we are making reference to the fact that what Q equals MC change in theta. This is the general formula. And in this case here now, we are asked for the ratio of specific heat capacity of one guy relative to another guy, taking into consideration that what Q is the same for both of them. So in this case here now, it means I can have that what Q, the quantity of heat for P, which is abiding by this formula, should be equal to the quantity of heat for Q. The quantity of heat for P should be equal to the quantity of heat for what? Q. That's why we are told that what? They are supplied with the same quantity of heat. QP is equal to what? QQ. The quantity of heat in P is equal to the quantity of heat in Q. As such, representing, I can say MP, you have here C, specific capacity of what? P, then change in temperature of P should be equal to M of Q, C of Q, and change in temperature of Q. So, two objects are supplied with the same quantity. You are having that what? Temperature is observed different here. In this case here now, we are taking into account that possibly the mass is also what? The same. So here now, if I'm to make CP, not the alphabet representation, P before Q, if I'm to pick the specific heat capacity, which is alphabet C, on top of what? Alphabet Q, then it's easy for me to say that what? The mathematical shift will be such that what? I'll divide both sides. I'll be dividing, let's transfer this up. Divide both sides by, I want my what? I want my Q out of the way under this part here now. So I'll be dividing both sides by, check it out, MP, change in theta P, and CQ. Let's do that first. Let's divide by this first so that we don't mix things up too much. We are going to have that when we do that, MP Cp, change in theta p, will be over mp alongside what? Alongside change in theta p, being equal to the other side, mq cq, change in theta q, over, you are going to have mp change in theta p dividing. Over here, this cancels out, this cancels out. Cp is left here to be equal to what? Mq, Cq, then change in theta q over mp change in theta. Now, having this in place here, you can see that we can now bring out, divide both sides by Cq. Divide both sides by Cq. And doing that, I would have Cp over Cq is equal to Mq Cq change in theta q over Mp change in theta p over Cq. Cq tends to cancel out. So you have that Cp over Cq should be equal to Mq change in theta q over Mp change in theta p. But looking at this question, we're meant to have heat capacity rather than specific heat capacity, since we are not given what? The mass in the question. So that is what should be the question. But let's push forward quickly. Let's get what our value are for what our temperature changes. Note, we are told that for the temperature change in P, we observe it to be twice that of Q, meaning that what? Change in theta for P is equal to twice that of what? Change in theta for Q. So if you are having that what? Change in theta of Q is a single value 1, then you are having that what? Change in theta for Q will be 2. So for P will be 2. So putting that in, we have that Cp over Cq is equal to Mq. The value on top here is times change in theta q over Mp multiplied by 2 change in theta q. This guy cancels out this guy, leaving us with Cp over Cq being equal to 1 here, remember? 1 over 2, then in bracket of Mq over Mp. So 1:2 is what we are coming to terms with. But I'll be making modifications. You know that what? Past questions in Nigeria, you would have 1 or 2 mistakes popping up from there. Now, for questions like this, we don't end up having any other alphabet attached to them. So all what we have solved here now, we can say that Cp, Cq, what we are looking for is 1:2 as the final click of what we are expected to get from here. So all this now, I have shown you the accuracy part. We are trying to be accurate. That's why I tried to what? Show you the steps involved. But remember, we are working with speed. It's not just about accuracy in your UTME examination. Speed is also of the essence. So having to be solving step by step, here might tend to eat up your time. So what is the fast approach to it? First and foremost, like I said, in this case here now, once you are talking about specific heat capacity, then what you'll be going for is what? C, alphabet C, specific heat capacity. But in this case, since mass was not given in the question and anything about mass was not mentioned, then instead of specific heat capacity, we're expected to have heat capacity being considered here. And what do I mean? We have that heat capacity, H, is the product of mass times specific heat capacity. So rather than having Q as being equal to MC change in theta, I can just say Q equals to H change in theta. merging mass and specific heat capacity together. Remember, heat capacity is the product of what? Mass and specific heat capacity. So I'll be working with just these two parameters. And to fast track it, I'll be saying that what? We are given, take your change in temperature for the Q part, change in theta for Q, you are going to take it as what? 1. Then since we are told that what? Therefore, since you are having that what? Change in theta for P to be equal to what? 2 times of change in theta for Q. Therefore, we are going to say that what? Change in theta for P should be equal to what? 2 times 1, which is equal to what? 2. Use number values as fast as possible so that what? All the alphabets would not create any mix-up. So this is method 2, a faster approach. Method 2. So all I'll just be considering will be what? The quantity of heat mentioned, which they said is the same. Same quantity of heat, note here, and the what? Change in temperature. These two are the key parameters we are using. So I'll be saying that what? QP here should be equal to what? QQ here without any problem. Then you should have that what? HP, specific capacity for this guy, multiplied by change in theta for P should be equal to heat capacity for Q, sorry, instead of specific capacity, we are now working with heat capacity, multiplied by change in theta for Q. Put in your values. HP multiplied by 2 should be equal to HQ multiplied by 1. You divide both sides by what? HQ and 2. You want to remove 2 away from this side, and you want to what? Remove HQ from this side. So I'll be divide both sides by 2 and HQ. You see the reason now. We are going to have HP times 2 over 2 times HQ should be equal to HQ times 1 over 2 times HQ. So HQ cancels out HQ. You have 2 cancelling out here. That means heat capacity for the P part over heat capacity for the Q part is equal to 1 over 2, which is the same thing as 1:2. The same answer, but you have that what? This step is longer, working with alphabets. As much as possible, switch into converting into number values given. The interpretations, put in number values for them as quick as possible. We look at the next question without wasting our time. Remember, this is under heat. Let's see if we have a question under electricity next, or if it's still going to be heat, we go for it. You have the longer approach where you are translating alphabets back to back, and you can easily go for what? The quick approach, which you substitute the number values, give a representation of the number values immediately before you start what? Solving. Then it minimizes the use of alphabets back to back. So remember, this first step was used to what? Show you what the whole process entails. What is cancelling what? From what you already understand in the formula instance. So we have another question here. Check this out. Under electricity now. We are told this. Okay, this is not ratio per se, but something interesting under electricity, something a little related. What problems, what problem questions, which at the end of the day requires calculation. It's not just for you to pick answers. A circuit has a resistance of 200 ohms. Full stop. The resistance of the circuit can be reduced to 120 ohms when question mark. I put in the options for the sake of clarity when I'm giving my explanation. A, we are told when a 300 ohm resistor is connected in series. B, a 150 ohm resistor is connected in series. The next, okay, this is 80 ohms. 80 ohms here. Then C is 150 ohms resistor is connected in parallel. Yep, parallel. They're not forgetting the next part, the last option D, a 240 ohm resistor is connected in series. Now, here's the catch. It's usually expected. Something to note about series connection and parallel connection when it involves question twists like this. Anytime you are 2 period. 2 times 12. You can easily work with what? 24. And as such, I can say that what? 600 should be a best bet to using it. You don't want to go for too big a value. Check 12. Check 2. What are values that can easily divide? We taking into account that what it should be an hundred of value. 600 should be the next. So 600 is what we are using here. We have that 120 will go in 600 5 good times. Then minus, you have 200 will go in 600. You have 3 times. Here, equal to what? 1 over R2. So from here now, we have that 2 over 600 should be equal to 1 over R2. And here, cross multiply 2R2 equals to 600. Dividing both sides by 2, you have R2 to be equal to 300, which is certainly not what we are having here. So certainly it means that what from the question set, let's see. Question 38. So certainly, as I would expect, the mistake is actually from what? Is from the question. The mistake is actually from what? The question. Because based on what we have here, you are having that what? Instead of the what? Answer here being series, this guy is actually parallel. The option provided indicated that what? That's based on what was solved at the back. What we have in front is showing the option as being series. But whereas what option was actually solved at the back had the answer being in what? Parallel. So you can see that this would not be the answer. 150 here would not be the answer based on what we just calculated. So we should have option C as our 150. And we have option A. So option A would be the correct answer, 300, as we have shown in our calculation, 300 ohms. So note, please, anytime you are solving, as much as possible, it's not all answers you have at the back of your what question pack that are actually correct for certain publishers. For certain publishers, you have a large credibility, talking about Nigerian sequence. Some publishers have a large credibility, while some might not that have much. So please bear that in mind. In this case here now, you can see effectively, based on the two values we are given, we want to what? Reduce to 120. We are not told that 120 is the second resistance connection. No. 120 is the final answer. That is why we are writing it as 120 here. The resultant connected in what? Parallel. If it was to be series, then we'll have done what? Direct addition. Anytime you have what? Series connection, it's a direct addition. I'm sure you get that. So please note, check out all the solutions. The final answer we are arriving at is actually what? 300 ohms. In what connection? In parallel connection. Note, to arrive at what? A lower reduced resistance, it must always be in what? Parallel, and not in what? Series. So that's why at a start, we'll have tested only option A and option C. And mere solving this, it's easy for us to figure out that what? Option C is not the answer. We don't have 150 from the calculation. So we move on. You can't cram answers at the back. I repeat again. You can't cram answers at the back of your question pack. You need to understand what they are asking or what they are explaining. You need to understand exactly what is the question all about. What are they asking me here? The next one, back to what? Back to heat. Question under heat and temperature. We have this. Good. You can see that what in this instance here now, it was stated clearly, and that was what was not done in the previous question. If you have a view, you can take a replay. You get to see what I'm saying. For question 3 now, check this out. We are told that two liquids, X and Y, having the same mass. Note, you can see that something was mentioned about mass here. They are having the same mass. You can't be asking about specific heat capacity and you are not making comments on what is happening to the mass. Because ratio questions, you shouldn't have any alphabet at the end, just numbers. So here now, having the same mass are supplied. They are supplied with the same quantity of heat. So quantity of heat is the same here. Full stop. If the temperature rise in X is twice Y, the ratio of the specific heat capacity of X to that of Y is question mark. Exactly similar questions from different years, only that what alphabet twist with clarity to what is happening to the mass. That's why I'm bringing this back. So normally I will have ignored this, that is the same answer we are going to get. But why I'm bringing this now, you can see here that something should be said about what your mass, because the formula does not change. We are having Q to be equal to MC change in theta. That's always the formula. In this case here, we are told that quantity of heat is the same quantity of heat. It's only such that what X is twice Y. That's the only condition we are following for temperature rise, meaning change in temperature. If I'm to state this, I will say that what N X, mass of X, is equal to mass of Y. I can represent it by 1, not having any problem. And why am I going for 1? You can use any number. But because 1 reduces your instance of having to depend on calculator, you can easily multiply anything by 1 and you're good to go. Remember, for this question type, ratio questions, you can easily use what? 1 as a value. And you won't have much instance to worry about talking about what? Calculators. So mass being equal to each other, we are having 1. We push forward. Temperature rise in X is twice that of Y. So it means that what? If change in theta for Y is equal to 1, then I will have that what? Change in theta for X will be equal to what? 2 change in theta for Y. And I'll be working with change in theta of X to be equal to what? 2 times 1, which is equal to 2. So I'll be using 2 as the change in theta for what? X. We are to compare heat energy. Q equals to MC change in theta. So the heat energy here for X should be equal to the heat energy for Y. MC change in theta for X should be equal to MC change in theta for Y. putting in our values. M here is 1, multiply by C, multiply by change in temperature twice. I'm using 2 here. It will be equal to M1 here, CY, and I'm using 1 here. So for Y part, we have 1. The change in temperature is equal to 1. From here, 2CX is equal to what? 1CY. 1CY. When you divide both sides by 2 and 1, remember, you want to remove 2 away from here, and you want to remove CY from here. So that's why you have to divide both sides by 2CY. 2CY. CY will cancel out here, remaining the numbers. Here, the number cancels out, remaining the alphabet. Note the interchange. Anytime you want to find ratios, always eliminate the alphabet away from the what? The right hand side, and leave the what? Alphabet only retained at the left hand side. Remove all numbers from the left hand side, but remove all alphabets from the right hand side. You can see that the final answer is still giving us what? 1/2. CX ratio CY is equal to 1/2. 1/2. Exactly the same answer we got at first. Exactly the same answer. And note this. Remember that what? It is based on teacher's explanation sequence. That's why I have to state out my parameters. Some of these things, you can easily beat them. Talking about exam conditions, you are working for yourself and you are working to beat time. So there might be no need for you to what? Write out certain parameters, and you are good to go solving your questions. Let's look at the next one quickly. We've looked at question under electricity. We have looked at question under heat. We proceed again on to the next. All right. This is something similar under heat, but this time, instead of specific heat capacity, we're having it under linear expansivity. A question under linear expansivity. Check this out. Under linear expansivity, we're told that two metals, P and Q, two metals P and Q of length L1 and L2. Note the word L1 and L2 are heated through the same temperature difference. Through the same temperature difference. Through the same temperature difference. Full stop. If the ratio of the linear expansivity of P to Q is 2:3, and the ratio of their lengths is 3:4, comma, what is the ratio of the increase in length of P to Q? Remember, anyone which is mentioned first is always the one that should be on top. So linear expansivity. The point is now, do you know the formula for linear expansivity? Let's have it. The formula has not changed. It remains that what? Alpha, linear expansivity, denoted by alpha, alpha has always been equal to change in length over original length multiplied by change in temperature. But follow the conditions given. We are having that what? The ratio of the linear expansivity, meaning that what? Alpha of your P over alpha of Q is giving us 2 over 3. Remember, ratio means division. 2 ratio 3 means 2 divided by 3. Furthermore, the ratio of their lengths, the lengths which have been represented by L1 and L2, L1 for P, L2 for Q, we have that what? L1 over L2, the same thing as LP over LQ. LP over LQ is equal to 3 over 4, where we are to pick the temperature values to be the same. Note, we are told that what? The temperature difference is the same. They are heated through the same temperature difference. They are heated through the same temperature difference, meaning the temperature value for the first is equal to the second. And remember, we can easily use 1 to represent them. I've told you that before now. You can see it here. The same mass, we said first mass is equal to second mass, equal to 1. It takes out excess what? Calculation from your work. So look at what we are going to do. We are picking that change in temperature, change in theta for P will be equal to change in theta for Q, and you are using 1 to represent it. So back to the formula. This is what we are using. Change in temperature is what we are going for. When we tend to cross multiply these guys, you tend to see that what? Since we are saying that alpha is equal to change in length over original length, then change in theta. If we cross multiply, okay, let's use naught here to represent original length. The moment we cross multiply, I can easily say that change in L is equal to alpha L naught change in theta. What are we making reference to? We want to consider the change in length. Remember, it is about the ratio of the increase in length of P to that of Q, not the difference. In the first question, we are making reference to quantity of each Q, and we are saying that both of them are equal to each other. We wrote both of them beside each other because this is always the sequence of what you will get anytime questions like this arise. It's either they are telling you that what? The two things you are going to compare are going to be equal to each other. If they are not equal to each other, guess what they are going to say? They are going to tell you that what? The ratio of the increase in the length. And to do that, you are already giving ratios inside the question, meaning something divided by something. The best bet is to pick this formula and say that what? I can always write the change in length for P to be dividing what? The change in length for Q. And I'll place it with respect to what I have here. Alpha of P multiplied by the length of P, original length of P, multiplied by change in temperature of P, all over. The same thing applies to Q because change in length, this is the formula. So I'll have alpha of Q multiplied by original length of Q multiplied by change in temperature of Q. See what happens. We said that for change in temperature, the value is equal to 1. But here, we've easily been able to coin out change in P over what, alpha of P over what? Alpha of Q. Meaning that this side over this side, we have a value for it. Similarly, this value over this value, we have a number for it. This value on top of this, we have 1 to be written. As such, I can say that delta LP over delta LQ is simply first part 2 over 3 multiplied by second part 3 over 4 multiplied by 1 over 1. And you are good to go. Playing with the numbers. 3 cancels out 3 here, 2 here 1, 2 here 2. You discover that change in LP over change in LQ is going to be equal to 1 over 2, which translates to 1:2. And please, it's just a coincidence that our answers are tilting towards 1 over 2 or 1:2. You don't have to now assume that, oh, anytime I see 1:2 there, then the final answer is there, is 1 over 2. Please note, we are following the sequence of the alphabet lettering. We have P first before Q. That's why we are having P on top and we're having Q under. Sometimes they can easily change it. That's why we're saying pay attention to details. If you are told to find the increase in length of Q to P, that means that instead of 1 over 2, your answer should be 2 over 1. So don't make that mistake of not paying attention to exactly what you are being asked. We push on to the next one. Okay. Interesting. So we have another one. All right, all right, all right. This one says under electricity, an electric generator, has an EMF of 240 volts and an internal resistance of 1 ohm, full stop. If the current supplied is 20 amps, when terminal voltage is 220 volts, comma, find the ratio of power supplied find the ratio of the power that is supplied to the power dissipated. So we are to find the ratio of the power supplied to the power dissipated. Calculate the power supplied to the power dissipated, and you are good to go. So, having to solve this question here, you ask yourself, What is the formula for power? Because it's very key. Anything you are doing here, pick the basics. Power supplied is actually considering the EMF, because the original voltage coming is actually what, 240. You work with that subject to the current being produced. We have current value 20 amperes. We work with that. Also knows we are given internal resistance in the picture of things. So you agree with me that I can easily say that in the context of what we are having here, power supplied, power normally is voltage times current, or you say power, okay, let me represent this, P equals to VI, or you are saying P is equal to I square R. In this case here now, power supplied will be equal to VI, but note, it's going to be what? Watch. Instead of VI, but this will translate to EI. Why am I using EI? EMF. Note, the generator has an EMF. That is the original supplied voltage before you now have internal resistance affecting and creating a drop in the total value. So you have that the original voltage that is supplied is actually the EMF. EMF times current. And if I'm to calculate that, the EMF is given as what? 240 multiplied by the current, 20. And you end up arriving at 4,800 watts. Checking here, 2 times 24 is 48. And we have the 2 zeros attached. Here now, note, although 240 volts was supplied, the working voltage is no longer 240. It is now what? 220. There's a reduction in the voltage due to what? Some losses. And that's why they are saying power dissipated. The power wasted. Power dissipated. Also known as power loss, becomes equal to, we said I square R. But in this case, it becomes I square small letter r, because internal resistance is representing the what? The wasted power. Is a function representing what? What you will use to calculate the what? The total power that is lost or wasted in the system, maybe converted to heat or any other thing. So we have that the power loss is calculated using the resistance, the internal resistance in this case. So we are going to have that what? Calculating our P loss. Let's call this PS. This is PL, power loss, will be equal to I value, current in this case here, which is 20 square, 20 square, multiplied by our internal resistance, having a value of what? Oh, sorry, we calculate our external resistance. My apologies. We calculate our external resistance here. Power loss, I square R. And to calculate the value of R here, we have to use what our EMF formula says and stipulates. Here, what we ask is power supplied to power dissipated through the what? The wires that are being used. The power is lost based on the what? Resistance. External resistance. The internal resistance is affecting the generator that is supplying. So check this out. This is what we mean. Let me clean this. You will discover that what? Based on EMF. EMF has always had the formula I into bracket big R plus small r. I into bracket big R plus small r. This will help us get the external resistance on the wire which we are using. Remember, internal resistance only affects the generator, the cell you are using, the battery you are using. That is what the internal resistance is affecting, not the what? The general power loss due to transmission. So we have that what? EMF given to us is 240 here. I current is 20 here. Your external resistance, we are looking for it, added to 1. Dividing both sides by 20, you have that what? 12 is what you have here, equal to R plus 1. Moving here, 12 minus 1 becomes equal to R. Therefore, R is equal to 11 ohms. That is the value of the what? External resistance, 11 ohms. Having 11 ohms, use it to calculate what? The power loss. Power loss. I square R, and you have 20 square multiplied by 11, and you'll be having 400 times 11, which gives us 440, 4,440 watts. Remember, it's the ratio we are asked to calculate. Ratio of power supplied to power dissipated. We are going to have the power supplied over power dissipated should be equal to 4,800 over 4,400. And when you divide this through, zeros cancel 0. 44 and 48, you are familiar with the fact that what? 4 will be the dividing number, and the up value 12, the down value 11. So 12 over 11 will be the final answer. Now, please note the length of what we keep solving. Note the length of what we keep solving, because that is why we are bringing it. The good, the bad, the ugly of UTME examination every year is what we present to our students. And as such, make up your mind on what you want to do for that exam. Understand that what Jamb operates by psychological war. They are actually engaging in psychological warfare. The game Jamb is playing is psychology. They want to see how best the students can think in terms of working by the rules of the examination, majorly. Much of the questions are not difficult. That's why you can have people scoring 90 over 100 in mathematics. Our students, one of our students had that previous year. 90 over 100 is achievable in mathematics, where we used to think, oh, it has plenty formulas, or you have to, it needs time, it requires time for you to solve. No, people still score something high as that in such subjects. So it's not limited to only biology for you to get that. In this instance here now, 12 over 11, but look at the length of what we saw from here downwards. Application of different formulas. Are you in for such? Do you have what it takes solving questions like this? So when you say a question like this, if you know that what you are not prepared for it, and in all of this, I have not used any calculator. So you are just deceiving yourself and wasting your time. When you want to solve a question like this, and you're looking for calculator on the screen of your computer that day, you don't need it. Remember, it's not how far, but how well. The journey of what you are engaging in is about how well you are prepared for this examination. And like I would always shout it, please endeavor to scan through your questions, answering the non-calculation first. Endeavor to scan through the calculation question, the whole question set of your physics, and answering the non-calculation first. And you have now seen that what, although this appears easy, oh, this is just ratio. Oh, is it just to multiply maybe 2 times 3 or 3 times 3, then 2 times 4? No, that's not how it works. There are certain formulas embedded which you must use. It requires time. Take questions like this, ratios, questions involving ratios under heat and electricity as a calculation question. 40 questions are thrown at you. If you have about 17 questions that are non-calculation, make sure you answer them first. And let's play by the rule of the game. See what happens. When you are able to answer 17, for example, 17 questions has been non-calculation, you are increasing your chance and your speed. I never said your accuracy because you might end up missing some of the questions. So here, 17 non-calculations. The average time you end up using to solve non-calculation is about 20 to 30 seconds. 20 to what? 30 seconds. 20 to 30 seconds is the amount of time. So on the average, let's assume that what? You are using 30 seconds, for example. In total, and you are using around 30 minutes. You want to what? Clock 30 minutes. My students, and I can tell you over the years, we have them using less than 8 minutes. I am giving you the worst case scenario. The worst case scenario. 8 minutes, you are good to go answering more than 17 questions. If you know what you are doing for this examination, are they forcing you to write it? If yes, then whatever comes out of it, it's your fault. If you are being forced to write, nobody forces people to write Jamb. And you cannot be flexing and you want a very wonderful score. It does not happen. Paying attention to the details will help you. Out of 30 minutes, you using 8 minutes will leave you with what? 22 minutes. It means 17 questions, 8 minutes. You can capitalize on the remaining 23 questions if they are calculation questions and you answer them within what? 22 minutes. That is what you'll be fighting for. And it can be bad, and you need to be able to scale this, cutting this into at least more than half. Meaning that what you shoot it high, and let's say you are able to answer 13 questions. Check it out. 13 plus 17 means you have answered 30 questions. Would mean you have answered 30 questions out of 40. So whatever happens, that translates 30 out of 40 converted to 100. 75. You are fighting for 75 marks. You having answered 30 questions out of 40. You are fighting for 75 marks. It means whatever is happening, you are shooting your shots towards 75 over 100 in your DCME examination. Remember, your study part is not just here to teach you the book. We also teach you the numbers. We teach you how to crunch the psychology of the examination you are writing. This is what I'm telling you for physics examination, and that's why we are different from other platforms. Have this at the back of your mind. Here is the deal. Your target is what? Aiming for 75. So if worst come to worst and you are shooting, Jamb is shooting you and cutting your marks down, you shouldn't be able to what? Get marks out below 50 if you are that poor. You shouldn't be marked down below 50 because the average UTME, the average university requires you to have at least 200. And certainly, physics and chemistry is what scares students the most, specifically physics. So, know how to play with what? With numbers. The
aim of passing UTM examination is centered on your time management alongside the questions set which you are having. I would always pray that what you encounter favor in the examination. If bulk of it is actually non-calculation, trust me, you get to finish physics in the space of 20 minutes. You won't use all the what the 30 minutes arrangement time calculation. And that means that what you can have enough time to spread across your chemistry and other subjects. If you are writing biology, remember I say that what for biology students, your 40 questions in 30 minutes thereabout, you should be through with it. Within 30, 15 minutes, okay, let's not, for some people who might be getting scared. Within 15 minutes, you should be able to answer the 40 questions in biology. Yes, it's something we are all used over and over again. And that's using a 20 seconds count, not a 30. The 20 seconds count. Because some people will be like, how is that possible? 15 minutes for 40 questions. Yes, on a 20-second count for biology, there is no calculation per se in biology. So you can always make it count. I'm trusting excellence as you write this examination. I would say we call it wrap up today. Taking questions with regards to ratios, questions on involving ratios, constants, and electricity. I'll say that I'll come your way at the end of the step.